Today, we'll be discussing how to represent compounds in a chair conformation. So before we proceed, we are going to give the general representation or the general diagram of a chair conformation. In representing a chair conformation, substituents are usually placed in up and down positions. We can have down, we can have up at a particular position in the carbon, we can have up, we can also have down, we can have up, we can have down, we can have up in a particular position, we can also have down in a particular position. Then the last carbon, we can have the up position here, we can also have the down position here. So let us go further to represent some examples. So in some examples, let us consider this compound 1-bromo 3-chlorocyclohexane. So we are going to give a detailed step on how to represent this compound in a chair conformation. The first step we are going to take is to draw the structure of this compound before we now transfer the structure to a chair conformation. So this is 1-bromo 3-chlorocyclohexane. So we can start our numbering by numbering this position 1, 2, 3, 4, 5, and 6. So we have succeeded in drawing the structure of 1-bromo 3-chlorocyclohexane. So the next step we are going to take is how to represent this molecule in a chair conformation. So before we proceed, we are going to explain further the meaning of the wedge bond and the dash bond and where you can actually place them in a chair conformation. The first one we have here is the wedge bond. So when you have the wedge bond is represented in this form, a thick bond. So when you have a wedge bond in a molecule, it simply means that the bond is coming out towards you. Therefore, in the chair conformation, the bond should be in the up direction. So the next one we have is the bond represented in dash. For example, the bond attached, the carbon to bromine bond is represented in dash. So for you to represent this type of bond in a chair conformation, it means that the bond is going back away from you, which is in the down direction of the chair conformation. So having a good knowledge of the wedge and the dash bond and how to represent molecules in a chair conformation, then we can proceed in representing this molecule in a chair conformation. So I've drawn my chair. So the next step to do is to draw the up and down bond. So I can have here as down, this is up. Then going further here, I can use this as my guideline. I can have this as up, here is down, here is up, here is down, here is up, here is down, here is down, and here is up. I can have here as up, I can also have here as down. So I've represented all the bonds in the 6th position of carbon in the chair conformation. So the next thing to do is to place my substituents. So as we have already discussed, when you have the dash bond, the dash bond means the bond is coming out towards you, which means it should be in the up direction. So the first thing I will do is to number my chair conformation, my chair diagram. So I can start the numbering from any position. So if I start from this position, I can number here as 1, can number here as 2, I can number here as 3, I can number here as 4, I can number here as 5, and this position is 6. So where you start numbering doesn't actually matter. You can start numbering from anywhere. What matters most is the position you place the bromine and the chlorine substituents. And if you have a look at this diagram, you will observe that the bromine is in the 1 position and the chlorine is in the 3 position in the 6-membered ring. And bromine is in dash bond, and dash bond means that the bromine should be in the down bond in the position in position 1, and chlorine is in position 3 and it should be in the up bond in position 3. So I can confidently put my bromine is in 1 position and it is down, then I can put my bromine position here. Then chlorine is in the 3rd position and wedge bond means it is up, then I can put my chlorine here. Then the other parts represent hydrogen. I can have hydrogen here, I can have hydrogen in these positions, I can have hydrogen, I can have hydrogen, I can have hydrogen, 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 and hydrogen. So this is how to represent this molecule in a child conformation. So if I choose to renumber my child conformation, then I can also have this diagram again. This is down, this is up, this is down, this is up, this is down, this is up, this is up, this is down, down, this is down, this is up, this is down, this is up. If I change my numbering, let's just say I'm starting to number from this carbon atom, I can go from this direction: 1, 2, 3, 4, 5, and 6. So if I start in this direction, bromine is in the 1 position and it is down. So I can have my bromine in this direction. This is my bromine in 1 position. Then chlorine is in the 3rd position and it is up. Then I can have my chlorine here. So these 2 diagrams are the same. So it doesn't actually matter where you start numbering from. Then another example is, let us consider how to represent this molecule, 1 amino, 2 methyl cyclohexane in a child conformation. So the first thing you are going to do is to draw the structure of this compound. So suppose you are given this compound and you are asked to represent this compound in a child conformation. So I will first of all draw my chair diagram. Then the next step is to draw all the bonds in the chair diagram. I can have here as down, up, down, up, up, down, up, down, up, down, down, and up. So next thing to do now is to number my chair diagram. I can start numbering from anywhere. So let me start numbering from this particular carbon atom. This is 1, this is 1, this is position 2, this is position 3, this is position 4, this is position 5, this is the last position, which is position 2. Then I'll also number the molecule which I have already drawn. This is position 1 and this is position 2. That is the 1 amino 2 methyl cyclohexane. So next thing to do is to place this substituent in the chair diagram. The amino position is in position 1 and the dash bond means the bond should be down. So I will put my amino position here, which is the amino position here. Then the CH3 is in position 2 and position 2 means up. So I can put my CH3 here in this position. So this is one of the ways you can draw this diagram. Another way you can also draw this diagram is I can also redraw my chair diagram. I can also number. This is down, this is up, this is down, this is up, this is up, this is down, this is up, this is down, this is up, this is down, this is up, and this is down. Okay, I can start numbering from this position. I can call here 1, I can call here 2, I can call here 3, I can call here 4, I can call here 5, and I can call here 6. So placing the substituent, the amino position is in position 1 and it is down. So I can have my amino position here. This is NH2. And the methyl group is in position 2 and it is up. So I can have it in this position. This is CH. This is CH3. So these are the ways you can represent molecules or compound in a chart conformation. So in most cases, the structure of the compound will be drawn and you'll be asked to represent it in a chart conformation rather than giving you the name to draw the structure first before converting the structure of the compound to use a chart conformation. So please, if you enjoy watching my video, like, subscribe and share. Then if you have any question regarding to what you have watched so far, I would like to see your questions in the comment section. Thank you.